Hi students, problem number 22 in current electricity. The potential difference between the points P and Q in the given circuit is. This is the circuit and the four options are 5, 10, 15 and 20 volt. Okay, now you can look at the circuit. There are three closed loops A, B, C, D, E, F, A, the larger loop. Then A, B, E, F, A is a smaller loop. Then B, C, D, E, B. But this loop here, there are 2 points. So this point is P and this point is Q. We have to find the potential difference between the 2 points P and Q. They are not in contact. So this path BE is open. This branch of the closed loop is open. No current will flow in the middle arm. Why? Because P and Q are disconnected. Okay. So we have to find the potential difference between P and Q. Vp minus Vq we have to find out. Okay. Now I will apply Kirchhoff's voltage law. Kirchhoff's voltage law to the closed loop, that is a larger loop. A, B, C, D, E, F, A. So A, B, C, D, E, F, A. So Kirchhoff's voltage law. Mathematically, we have done many problems in the earlier classes. The algebraic sum of the I into R product is equal to the algebraic sum of the EMFs. Okay. So now you can see, start from A to B, there is a resistance of 1 ohm and a current of I ampere is flowing. So 1 into I. So I will write 1 I, then this 2 ohm into I. So between B and C, the IR product is 2 into I. Next, in this branch CD, there is a 2 ohm resistor and the same current I is flowing. So plus 2 I. Then from D to E, the resistor is 1 I. So this is 1 into I. Then from E to F, there is a 2 ohm resistor. So plus 2 into I. F to A, there is a 2 ohm resistor. So the IR product is plus 2 into I. So we have completed one loop. Okay, we have completed one full loop. A, B, C, D, E, F, A. Okay. So the algebraic sum of the current resistance product I have written on the left side of the equation. This must be equal to the algebraic sum of the EMFs in the same loop. So we start from A to B, there is no battery. B to C also, there is no cell or battery. But C to D, there is a cell and its EMF is 20 volt. Whether it is plus 20 or minus 20, that you have to understand from applying the sign conventions. So according to the sign conventions, you see that current I is leaving which terminal of the battery? It is the negative terminal. Since the current I leaves the negative terminal of this cell, this EMF is minus 20. So on the right hand side, I will write this is equal to minus 20. Then from D to E, there is no cell. E to F also there is no cell. But F to A, there is a cell of EMF 10 volt. The current is leaving from which terminal of the cell? It is positive terminal of the cell. Therefore, this 10 volt is positive. So, minus 20 plus 10. Have you understood? Okay, I have applied the sign convention for the EMF. So, this 20 volt is negative because the current I ampere is leaving the negative terminal of the battery. This EMF 10 volt is positive because the current I is leaving the positive terminal of the battery. Okay students, now you see what is on the left hand side. Let us see. So 1 plus 2 plus 2, 5. 5 plus 1, 6. 6 plus 2, 8. 8 plus 2, 10. So the left hand side is 10I. 10I is equal to minus 20 plus 10 is minus 10. Therefore, the current I is equal to minus 10 divided by 10. This is equal to minus 1 ampere. So this is very important information. Okay. So it is a minus 1 ampere. The current flowing in the circuit is a minus 1 ampere. That means, what do you mean by minus? We have assumed that the current is flowing in the anti-clockwise direction. That is from A to B, B to C, like that in the anti-clockwise. But the arrived value is negative. That means the actual current is flowing in which direction? Clockwise direction. That is the meaning, is it not? So we have assumed anti-clockwise current and got a negative value, means the actual current is flowing in the clockwise direction. This is an additional information in the problem. Okay students, now let us see what is the potential difference between P and Q. For that I will consider the incomplete loop starting from P and ending at Q. Okay, so I will apply Kirchhoff's voltage law to the loop. It is actually incomplete loop only. So we start from the point P. After P, B, C. So I will start from P, then go through the points B, C, D, E. D, E. After E, I will go up to Q. I cannot come back to P because it is incomplete. So for this, once again, I will apply Kirchhoff's voltage law. Now you see here, from P to B, no resistor. From B to C, there is a resistance. I want to find the I into R product. Current resistance product between B and C is how much? 2 into I. So I start with 2 into I. Then from C to D again 2 into I. So once again this is 2 into I. Then from D to E 1 into I. Okay, so this is plus 1 into I. Then from E up to B. From E to B there is a resistance of 1 ohm. But since it is disconnected between P and Q, no current is going to flow in this branch E to B. Therefore, the IR product stops with this only. Have you understood? Why there is no IR product available between E and B? Because it is open. This branch is open. No current will flow in this branch. So, 2I plus 1I. I have written. Now, once again, you start from the point P. We want the potential difference between P and Q, is it not? So this must be equal to the potential at P. Potential at P. Then from B to C there is no cell. Then from C to D there is a cell of EMF 20 volt. Now you tell me, is the EMF 20 volt positive or negative? It must be negative. Why? Because the current is starting from the negative terminal of the cell. Therefore, I will write this is minus 20. So Vp minus 20. Then D to E there is no cell, and E to Q there is a cell and 5 volt cell. But from which terminal the current is indicated in the circuit is positive terminal in this closed loop upward. Therefore, this plus 5 volt is positive. So I will write here plus 5. Then minus VQ. So this is the expression. So left side is 2 plus 2 plus 1 is 5. 5I. So left side is 5I. This is equal to this Vp minus Vq only I need. So Vp minus Vq I have put in brackets. What are the remaining terms? It is minus 20 plus 5. Is it minus 15? So I will write here it is a minus 15. We need the value Vp minus Vq. Now what is the value of current I? We have already found. It is minus 1 ampere. So I am going to substitute. This is 5 into minus 1 is equal to Vp minus Vq minus 15. So this 15 minus 15 is taken to the left hand side as plus 15. So 15. Then this is minus 1 into 5 is minus 5 is equal to Vp minus Vq. Therefore, Vp minus Vq is found to be 10 volt. Okay. So this is the potential difference between the points P and Q. So 4 options are given. So which option must be correct? It is option B. Okay. So option B is given as 10 volt. Therefore, option B. Okay. Option B is the correct answer. Option B is the correct answer. Have you understood? Okay. Hi students. Question number 23. a voltmeter of resistance 998 ohm is connected across a cell of EMF 2 volt and internal resistance 2 ohm. So the potential difference across the voltmeter. So this is the voltmeter having a resistance of 998 ohm. So when it is connected across the cell of EMF 2 volt, what will be the potential difference is asked. But the internal resistance of the cell is given as 2 ohm. So small r is equal to 2 ohm and the external resistance of the voltmeter is capital R, that is equal to 998 ohm. Okay. Now the current in the circuit, let us say this I ampere is the current supplied by the battery, okay, or cell. So this I is equal to EMF E divided by R plus small r. So the EMF of the cell is 2 volt. The total resistance in the circuit is capital R plus small r. So this is equal to 2 divided by, so capital R is 998 plus small r is 2. So that I is equal to 2 divided by 1000. 2 divided by 1000 means it is 2 milliampere. So 2 into 10 power minus 3 ampere. So this is equal to 2 milliampere. So the current flowing in the circuit is 2 milliampere. Now there are two methods to find the potential difference across the cell. One is the current I into R. So what current is flowing through this resistor is I ampere. So I into R must be equal to the potential difference directly. So the potential difference is equal to V, that is equal to I into capital R. So this is equal to 2 into 10 to the power of minus 3 multiplied by R is 998. So this is a 998. So if you multiply means it is coming as 2 into, this is 0.998. So this is equal to 1.996. So volt, 1.996 volt is coming. So out of the 4 options, which must be correct is the option A. Option A is correct. So option A is the correct answer. Now one more method is also there. So the potential difference across the cell must be equal to this EMF minus I into R, is it not? EMF minus I into small r. So 2 minus I into small r, if you substitute also the same value only is coming. Therefore option A is the correct answer. Therefore option A is the answer. Okay, that is the correct answer. I hope you have understood.